Hi friends, welcome once again. We are talking about demand forecasting, and in the last lecture we have seen what are the different techniques of demand forecasting. Broadly, we have the qualitative techniques and we have the quantitative techniques. So the basic difference between the qualitative and quantitative technique is that qualitative technique does not deal with the past data, how a variable has behaved in the past. They don't, in this technique we are not going to collect the data, whereas in qualitative techniques what we do, rather we take the opinions, we use our judgments. Okay, so you can say it is more of a qualitative assessment of what will be the forecast for the variable, rather it is with calculations and with quantitatives, right? We've seen there that there is a judgment method, there are the direct opinion method. So these are something which doesn't have anything to do with the data, numbers, etc. But in quantitative techniques, the foundation lies on the fact that the past data, if you take into account, it will give you a clue about the future. So you can forecast the future taking into account how the variable has performed in the past. So here we are going to take the historical data and do some kind of analysis and find out what is likely to be the forecasted variable. Okay, here our forecasted variable is demand, so we will be talking in reference to demand. So let's see what are the broader quantitative techniques. So the first technique that we are using here, quantitative techniques. So the quantitative techniques that are available for forecasting, the number one is the trend projection, right? So actually, whenever you ask any supplier, okay, that how do you project the trend? You are selling something. How do you project or how do you forecast your sales? He or she will respond that I take into account what had been the sales for the last few months or last few quarters or last few years, and based on that I try to forecast the future. Okay, so that means he or she is trying to gather knowledge about the trend, how the trend had been, and based on the trend he or she likes to forecast the future. Quite obvious, if you know the trend, how things are going, is it uptrend or downtrend or it is a constant trend, you can think how things are going to be in the future as well. So here we are doing the same thing under trend projection. Remember, whenever we say trend, we are talking about a time series data. What do you mean by time series data? Time series data means a set of data which has the values over time, right? So you have a time variable, time factor, and here are the variables. For example, population. If you write all the years and corresponding to the years you write the respective population, then it becomes a time series data. So when you have a time series data, then only you can find out the trend. You cannot find out the trend with one data. Okay, so better it is to have a long range of data, because long data will tell you what had been the trend. Okay, now the first technique that we are going to discuss is trend projection. We're trying to project the future trend. Here there are two methods. One is the visual method, and the other one is known as the least square method. Let's understand what is the visual method. Okay. So friends, as the word itself tells you, it is visual, means through eyes you are going to visualize. Okay. Quite a common technique, a very simple technique. What you are going to do here is that you are trying to find out suppose you have the year variable here and you have the sales variable here, or it could be demand variable here, and with all the corresponding years there are sales volume. Okay, and you want to know for this particular year what is the sales, right, or what is the demand you are trying to project. So what you can do is that you can graphically plot all these data. Okay, this is the time period, it could be month, it could be quarter, it could be year, and this is your variable. Say for example it is the demand. So you see the past demand values and you plot it. Okay, you plot it, right? Now when you plot, you try to find out what, or you can do one thing, you can just find out how this data is spread. For example, you can draw a line like this, so it can say somehow the data shows a uptrend, okay, a rising trend, and it is more or less like a straight line, right? So now that you have plotted till the available data, now you want to know for this particular year what is going to be the sales. So what you can do, you can just extend this line a little more, and then you can find out for this particular time period the sales is going to be this much, right friends? So what you are doing is that you are trying to find out the plottings, and based on the plottings you are trying to find out the direction or the trend or the shape, is it going upward, downward, whatever, and based on that you extend the line a little more, that will give you the projected, or you can say the forecasted value. Now the question is, when you go for trend, okay, so one thing you have to remember that this line can be a straight line or it can be having a different shape. So you have to identify the shape. If it is a curve, say for example, if the curve is like this, so you can say if till here you got it, so you can extend it somewhere here. This is your forecasted. If the curve is like this, so it has gone here, so it is going to be somewhere like this. If it is a S-shaped curve, so you know that this figure is going downwards there. So this way you have to project the trend. So it is simply by your visualization through your eyes. Okay friends? Now let's pick up the second technique, and the second technique is known as the least square technique. Friends, least square technique is more mathematical, okay, and it is more objective, you can say. You don't have to use your own eyesight and visualize it. Rather, it is a mathematical model to estimate what would be the forecasted value. Okay, let's start. But before least square, I would like to tell you, as just now I said, the trend could be a straight line. Okay, we call it, there can be a linear trend or it can be a non-linear trend. Okay. Linear means more or less it is like a straight line. It is like a straight line as it happened in our case. So if it is a linear trend, your equation is equals to y is equals to a plus bx. Whereas if it is a non-linear, there could be many types of equation. Whatever is the equation, you can do it, you can solve it. So when you have a least square method and you find that the trend is linear, then what you do is that this is your formula. Y is equals to a plus bx. What is y? Y is the forecasted sales that you are going to make, or forecasted demand. What is your forecasted sales or forecasted demand for the coming time period? What is A? A is a constant. Okay. And what is B? B is the slope coefficient. It is the slope, means the degree. And X is the time factor. Now let us understand. Let's not take a lot of pain in understanding this. We will take up a problem and I'll explain you how we got the value of A and value of B and value of X. But before that, just for purpose of basic, suppose you have this type of line. Okay, your A is this much. A is this point, this intercept. This is your time and this is your demand. Okay, as time increases, your demand is also increasing. You can see the demand is increasing. But even if the time is 0 or whatever is the time, you have a intercept. Well, let's not call it 0. Suppose you are starting at 1. So you will have a minimum sales of this much or minimum demand of this much. So this is A. As you go upward, the minimum this much is there, but additionally some more is there. Minimum this much is there, but additionally this is called the constant, which will never change. Whereas what is B? B is the slope, the degree with which this factor changes because of change in this. What is X? That is time. Because of time, how much the demand is changing, that will be captured by B. Let's understand how to calculate this A and B. I'll take up one example and let's understand how to calculate A and B, and once you know what is A and B, you can easily forecast what is the sales. Okay. So friends, one problem is in front of us. We have the years. You can check it is for 5 years, 20, 21, 22, 23, 24. We have the sales value given to us 100, 120, 130, 125, 140. If you sum it, let's call sales as y variable. Okay, y is equals to these variables, and when you sum them all, it is 615. As just now I said, the least square technique is y is equals to a plus bx. Now we have to get the value of a and b. The formula for a is summation y by n, and formula for b is summation x into y divided by summation x square. Simple, it's very easy. Once you have the y, let's set the x values. How do we set the x values? Let's start with the origin. Suppose this is the 100, 120. We take the midpoint, that is, say for example 130. You can take one period at the middle or somewhere in the middle and call it as 0, and as you go back, give the numbering as -1, -2, and as you come forward, give the numbering as +1, +2. Now this becomes your x, and when you multiply x and y, you get xy. You sum them all, you get 85. Just for example, 100 into -2 minus 200 this way, and you sum them, you get 85. Now you square this, x square. 2 2 is 4, 1 1 is 1, and this way you do the calculations and write the summation x square at the end, that is 10. Once these calculations are done, you set the values in their respective place. Summation y is 615 divided by n. N is the number of time period. We have 5 years, so we get 123. You have b 85 by 10, so it is 8.5. Place it in the equation. Ultimately, now the equation becomes a is this much, b is this much, but x is what? X is the time period for which you want to forecast the data. So 1 and 2 is known to us. Now we want to know 25. So 25 we will write as 3. So for 3 as a time period, you get the forecasted value as 148.5. Suppose you want to know for 2026. So you will have the forecasted, the x value will be 4. So you place it as 4. Here x means what? X means the time period. So x is 4th period. After the 0, 1, 2, 3, 4th period, you place the value as 4 and get the forecasted value. So this is how in a least square method we are trying to estimate the forecasted values of a variable. Why it is least square? Least square because we are trying to minimize the square of the errors. Okay, sum of the square of the errors. What is error? Error means whenever there is a difference between the actual and the forecasted value, there is an error, right? Error in forecasting, say for your common understanding. So you have an actual value and you have a forecasted value. Whenever you are forecasting, your idea is to get the perfect value so that there is less chances of error. So the least square technique will minimize this error. So sum of the squares of the errors will be least. Okay, and that's why it is called least square method. So I hope this is clear. Now let's move on to the next technique. That is we have done the trend projection here, and we have also seen how to do the least square. Now let's go to the very important and popular technique, that is moving averages. So friends, now we will understand what is moving average. So friends, generally what we do, suppose I have got 3 months data or 4 months data, and I'm looking forward to forecast the future months demand or sales. So I can take up one more technique. I can take the average of this 4 months, and then I can say, yes, this average is going to be the next month's or next period sales. Okay, yeah, it sounds logical. There is no harm in taking the averages. We can take the averages and then we can find out what is the likely forecast of the coming time period. Now, friends, as I told you, we have a long time series. Okay, suppose I have a time series which starts from, say, last 24 months. And based on the last 24 months, I'm going to predict what is the forecast of the coming month. Now, this last 24 months is a history, I understand. And I have to get the clue out of the history to know my future. But when we take, for example, the last 24th month, the month which I started with, okay, the first month of my time series, the first month of the time series is very far from the recent time period. Okay, we are standing here and we are talking about the 24 months backdated data. So we can say that the 24 months backdated data and the last month's data, if I take the average, this average is going to be not that perfect, right? It's not reflecting the perfect trend. Right? I have to take into account the very old data. I will take into account the very new data. And if I take the average, means I'm clubbing together old, new, all the data and taking an average value and predicting for the future. But this is not that scientific. So comes the moving average. Moving average means the average which will move forward and forward and forward. So I will take some average which relates to the very last, very old data. Then I will slowly come forward with the averages of the recent time periods. Okay, and this way it is known as moving average. I think if you have not understood, it's okay, because we are going to understand this with the help of an example. So for example, I have January to August, the sales data. Now I want to predict for September. Now for predicting for September, I can take the sales value and take the average of it. But I feel that it is not a fair practice, because January is quite a very old data and August is quite a new data, and old and new, if you club together, then it's not making that sense. So I'll go for moving average. So what I can do is that I can use 3 months averages, 3 months averages I can take up. For example, first I will take January, February, March. Take their average. If I am taking 3 months, okay, January, February, March. So 100 plus 120 plus 130, I take the average and I write here. Okay, so what is this? 100 plus 120 plus 130 and the whole thing divided by 3. I have written here. Similarly, I take 120, 130 and 125, take the average and write here. 120 plus 130 plus 125. You can check the values if there is any doubt, and you can write it here. Similarly, what is this one? This one is 130, 125 and 140. If you take the average, you will write it here. This way the things will continue. So see, we are getting some averages, but these are moving. This is having reflection of January's data. This is having reflection from February's data. This is having reflection from March data. This is having from the April data. This is having from May, and this is having from June. So I'm taking January also, but in an indirect manner, because ultimately what we are doing is that we are taking the moving averages. Okay, friends. So this way I get this is what is called smoothing. I'm smoothing the data. Data is getting smoothened out. I'll come to this smoothing little later also, but for time being, what we are doing is that we are going to smooth out the data. Why I am smoothing out? Because there could be some fluctuations in between, but if I take the averages in a forward going manner, then some of the fluctuations are omitted by doing this kind of averages. Okay, now if you ask me what is the September sales, so the September's forecasted sale is 148.3. Okay, so we will go this way so that it is more scientific also, and we are able to forecast it in a precise value, that is 148.3. Takes into account the effect of this on this, effect of this on this, or old values having effect here, then relatively newer is having there, and the recent values are having effect on here, and this is going to be the likely sale for the month of September. Okay, friends, so this is a simple moving average. So this is called simple moving average because there are other moving averages also, which shortly I will cover now. So friends, here we go with the next moving average technique, that is known as the weighted moving average. Just now we saw this one, SMA. SMA means simple moving average, and we have taken 3 monthly moving average. Okay, now friends, when I am taking this simple moving average, I am averaging January, February and March. Then I am averaging February, March, April. Then I am averaging March, April, May. This way I am continuing. But then why this weighted moving average has come? Weighted moving average has come because statisticians believe that, or even forecasters, they believe that if you are taking January, it's quite old. Its value in the present is less. Whereas February's value, suppose in 116.7, January's value is less. Value in the sense, not the numbered value, means it's old data. So its worth will be less here. February's worth will be little more from January, and March value will be highest in this average. Okay, means I will give less weightage to the old data and more weightage to the recent data. It's quite obvious, no? When you're forecasting is based on the recent trend that is going on, and the past very old trend has got less implications. So that's why I will give less weightage to the old value and give more weightage to the recent values. So how I will do this is called WMA, 3 months WMA. Okay, so how we do this WMA? WMA means weighted moving average. So what I will do, 100 I will give a weight of 1. 120 I'll give the weightage of 2, and 130 I'll give the maximum weightage, that is 3. So I'll do what? 100 into 1 into 100 first weightage, 120 into 2 because I'm giving 2 as the weightage, and 130 into 3 I'm giving 3 as the weightage for the month of March, and I divide with the sum of weights. Sum of weight means 1 plus 2 plus 3, which is equals to 6. Similarly, I will do this also, 120 into 1, 130 into 2, 125 into 3. See? So see, this 120 had a weightage of 2 in the first average. I mean, whatever will be the average, this is the average. But 120 will have a weightage of 2 in the second average, whereas 120 will have a weightage of 1 in the third average. So this way I will make the calculations of weighted moving average. So now I can say that yes, September is having a forecasted value of 152 if you go by weighted moving average. Okay, friends. So I think the moving average part is slightly clear. We can proceed with the advanced discussion now. So friends, we will continue this discussion in the next video. Stay tuned. Thank you for watching. Bye-bye.